Okay, problem number 1 on the review guide asks to find using LRAM to approximate the area under the curve y equals x squared from 2 to 6. So LRAM is left rectangular approximation. So what we do is we start with 2 and we're going to create 4 rectangles. So from 2 to 7, so our width is 7 minus 2. From 3 to 7. Excuse me. So 7 minus 3 divided by 4 rectangles. So you get 4 divided by 4, which means our width is going to be 1 unit. So from 3 to 7, we're going to draw 4 rectangles that have each have a width of 1. So I'll start on the left side because it's LRAM. So to find my height, I go up until I touch the curve, and then form my rectangle. Again, you only go as high as the curve. So the area of this rectangle right here is the width is 1. The length is going to be how long it is up to this y value. So I substitute 3 in for x. 3 squared. Area is 9. Rectangle number 2, I go up at 4 until I touch the curve. So that area is 1 times 4 squared. Again, I'm substituting the x value into the function. Then rectangle number 3, 1 times 5 squared. And then rectangle number 4, so there's my 4 rectangles. So if I add them up, so my total approximation is going to be 86. Okay, number 2. Express this limit as an integral. All we do with this, since we know that adding up an infinite amount of things is the same thing as an integral, and I replace all the c sub k's with x's. Delta x gets replaced by dx, and our integral goes from -4 to 3. Okay, number 3, find the various integrals. So again, just find antiderivatives. So antiderivative of 4 is 4x, and we're going to evaluate 4x from -1 to 5. So when you evaluate, you substitute the top number in first, minus, substitute the bottom limit in, the lower limit. So 20 plus 4 gives us 24. Okay, number 4, antiderivative. So I start with 2. So what I'm going to do is, again, add 1 to the exponent, and then divide by that new number. So my antiderivative is going to be x squared plus 8x. I'm going to evaluate it from -4 to 4. So when I evaluate, substitute the top upper limit in for x first. So I have 4 squared plus 8 times 4 minus, substitute the lower limit in, -4 squared plus 8 times -4. 16 plus 32 is 48, minus 16 plus -32, -16. So you end up getting 64. Okay, number 5. A snail travels at 0.04 feet per minute for 6 minutes. How far does he travel? So distance, so when you have a velocity versus time graph, the area under the curve is going to be your distance. So the rate was 0.4. So 0.4 dt, and it says for 6 minutes, so from 0 to 6. So I'll evaluate. My antiderivative is going to be 0.4t evaluated from 0 to 6. So 0.4 times 6 minus 0.4 times 0 is going to be 2.4 feet. Okay, number 6. It says evaluate this integral using a calculator. So to use a calculator, what I'm going to do is I'm going to put this function into the y1. So x squared times e, and e is, again, second natural log. So e to the 2x. Okay, and now to find the integral, I push second, trace, which is calculate. Number 7 is the integral of f of x dx. So we're going to calculate the integral from 0 to 4. And the area is 18,630. .74. Okay. Okay, some additional integrals. Okay, number 10, integral of e to the x. Integral from -4 to 6 of e to the x dx. Antiderivative of e to the x is just e to the x. And we evaluate that from -4 to 6. So you substitute the upper limit in first, minus, substitute the lower limit in. And so you have this, which is the equivalent of due to the negative exponent. Okay, number 11, integral from 1 to e of 2 over x. First off, I can factor out this 2. So this becomes 2 times the integral from 1 to e of 1 over x dx. Okay, you recognize that integral of 1 over x is the natural log of the absolute value of x, evaluated from 1 to e. So I have 2 natural logs absolute value of e minus 2 natural logs absolute value of 1. E and natural log cancel out, so it's 2, basically 2 times 1, minus the natural log of 1 is 0, so you get 2 minus 0, which is just 2. And again, you can put this into your calculator, it's the same thing. 2 times the natural log of e minus 2 natural logs of 1, and you get 2. Okay, number 12, antiderivative. So I have the 6 out front. So now I add 1 to the exponent. So -4 plus 1 is -3. And I divide by the new exponent. So 6 times -1/3 is -2. X to the -3. Which is the same thing as -2 over x to the third, evaluated from -2 to -1. So substitute -1 in for x, minus, substitute -2 in for x, and you get 2 minus 2 over 8, which is going to be 1 3/4 or 7/4. Okay, number 13, the integral from 1 to 4 of x to the -1/2. Add 1 to the exponent. Add 1 to the exponent, and then take the reciprocal, and that's going to be your coefficient. So our antiderivative is 2x to the 1/2, evaluated from 1 to 4. So this is the same thing as 2 times the square root of x evaluated from 1 to 4. So I substitute 4 in for x, minus, substitute 1 in for x, and end up getting 4 minus 2, which ends up giving you a solution or answer 2. Okay, number 14. I'm going to factor negative 36. So I have the integral of 1 over x to the 5th dx, which is the same thing as negative 36 integral of x to the negative 5th dx. Add 1 to the exponent. So I have x to the negative 4th. And take the reciprocal. So times negative 4. So when I clean this up, negative 36 times negative 1/4 is positive 9. X over x to the negative 4 is putting x to the 4th in the denominator. And since this is not a definite integral, it's indefinite. There's no limits. Plus c. Okay, number 15. I'm going to first convert this into exponential form. So I have t to the 1/2 minus t to the 1/7 dt. Same thing. Add 1 to the exponent. So 1 plus 2 is 3/2. The coefficient's the reciprocal. Minus 1. Add 1 to the exponent. 1 plus 7. Reciprocal. Plus c. Again, there's no limits, so plus c. So that's your antiderivative. And if you want it in radical form, 2/3. For t, it's the square root of t cubed minus 7/8, 7th root of t to the 8th. Which also simplifies to 2t square root of t over 3 minus 7t 7th root of t over 8, depending how far down you want to take it. But just exponential is okay. Okay, substitution method, number 16. So what you want to do here, or what you want to do is you want to find out whose derivative, either the numerator or the denominator, whose derivative makes something cancel. So I'm looking here, if I take the derivative s to the 3rd, I get s squared. Squared is not going to make the 4th cancel. But if I take the derivative of something to the 4th, I'll get something cubed. Cube can cancel. So I'm going to make u equal to 5 minus s to the 4th. So I have du equals negative 4s cubed ds. And then solve it for ds. Du over negative 4s to the 3rd. So I'm going to do my substitutions. 16s cubed over. I'm going to replace this inside with just u. And now I'm going to replace ds with du over negative 4s cubed. S cubes cancel. 16 divided by negative 4 is negative 4. So I'm going to pull the negative 4 outside. I have the integral of the square 1 over the square root of u du left over. And this problem is just like the previous ones we did. I'm going to change this into an exponent. So u to the negative 1/2. So I add 1 to the exponent. negative 1 plus 2 is 1/2, reciprocal. So I have 8 u to the 1/2 plus c, which is 8 square roots of u plus c, which is going to be 8 square root of 5 minus s to the 4th plus c. Okay, number 17, same thing. I know the derivative of x to the 5th is going to be something x to the 4th, which is going to cancel that x to the 4th. So I'm going to make u equal to x to the 5th minus 3. du is 5x to the 4th dx. And then dx is going to be du divided by 5x to the 4th. So now I do my substitutions. X to the 4th times u to the 5th. Again, this is my u. Du over 5x to the 4th. X to the 4ths cancel. The 5 I'm going to bring out front as 1/5 the integral of u to the 5th du. The 1/5 stays. Add 1 to the exponent and divide by the new exponent. So you get 1/30 when I substitute u back in, plus c. Okay, number 19. I'm going to use, this is my u. So u is y to the 6 plus 2y cubed plus 2 du, 6y to the 5th plus 6y squared dy. So dy is du over 6y to the 5th plus 6y squared. So when I do my substitution, I'm going to pull the 15 out front. 15 integrals of u to the 3rd times, now this has, I'm going to factor out a 2 here. 2 y to the 5th plus y squared, because I'm going to factor out a 6 down here. You'll see why in a minute.
Strange person came.
So,
oh, sorry, Mike, you're in here.
that's alright. Yeah.
Well,
Video. Sorry. So when I do my substitution, so I factor out the 6 and factor out the 2, so you see I have a y to the 5th plus y squared. They cancel. 6 in my denominator, so I have 15/6. So I pull the factor to 6 out. And I also have the 2 out front, all these coefficients. And now everything cancels except I have u to the 3rd du. So I basically have 30 over 6, which is just 5, integrals of u cubed du. Add 1 to the exponent, divide by it. So I have 5/4 u to the 4th, and u was and that's our final answer.